Hey everyone, in this video I'm going to be synthesizing and exploring some of the properties of a compound called tin tetraiodide. What you'll need is tin powder, which I made out of a block of very pure tin metal, a Dremel, and some patience, and iodine. This is very high purity crystal iodine that I just made. Okay, to start, place them in a test tube. Some iodine is added. And when you do this, you want to make sure that your tin is your excess reagent and that iodine is your limiting reagent. And the reason for this is that we're going to end up decanting this liquid. And if you have excess iodine, it'll be very hard to remove that excess iodine. Or if you have excess tin, it'll decant very easily. Okay. Some tin metal has been added to the test tube. Now, for this reaction to occur, we're going to need a solvent. And the two solvents that I know that you can use is dichloromethane and carbon disulfide. I've also heard of chloroform being used, but I can't say from experience whether or not that works. So I'm going to be using dichloromethane. Dichloromethane, the downside is that you have to use more of it, but it is a lot safer than carbon disulfide because it's less flammable. Okay. Okay. It's taken up in a pipette and added to the test tube. Immediately we see the color of dissolved iodine. Add a little bit more. Okay. Now we have this kind of brownish solution of iodine. And the next step would be to shake it to get it to stir. And over a period of about 30 seconds to a minute, we'll see the color of the solution go from this iodine color to a light yellow. So what's happening right now is the iodine in solution in dichloromethane is reacting with the tin to form tin tetraiodide. Right, well, I'll skip over this part and get back to you when the color has changed. And this is the color of the solution once it's done, a really nice golden yellow. And you can see the excess tin at the bottom of the test tube. So now I'm going to decant this into another test tube. Now that we have a solution of tin tetraiodide and dichloromethane, the next step is going to be to drive off the solvent. So I'm doing that by heating this in my alcohol burner. And once the dichloromethane has been driven off and boiled away, we'll be left with crystalline tin tetraiodide. So now, about what makes tin tetraiodide so cool? Well, what's really interesting about tin tetraiodide is it is a covalent compound. So where you might expect a metal and a non-metal to form an ionic compound, in this case, it's covalent. And its covalent nature is really evident by some of its physical properties. It melts and boils at really low temperatures, and we'll see that later. So anyway, I'm going to boil this down, and be very careful not to boil it all the way down because I don't want to decompose and start to boil the actual tin tetraiodide. So I'll get back to you once this is pretty much done. Alright, all the solvent was driven off, and as soon as it was a very low quantity in there, I stuck it in some cold water, and it crystallized out really beautifully, so I decanted it off, and this is what I'm left with. This really pretty kind of yellow-orange powder of tin tetraiodide. So onto its properties. Being covalent, like I said, it's going to have really low melting points and boiling points. So with heating it on my alcohol burner, I should be able to melt it. So there is still some dichloromethane in there, and we can see that start to boil away. So the dichloromethane shouldn't take too long to finish boiling away, and what we're going to be left with is a molten tin tetraiodide. And that should be a very dark color, like a really black color. I think I'm going to need a little more heat. Let me light my torch. Alright, now I've got my torch on a really low heat level, and I introduced the tin tetraiodide. So under strong heating we see the molten tin tetraiodide there at the bottom, and you can see a yellow vapor building up in the test tube that slightly resembles bromine but is more yellow. And that is tin tetraiodide gas. So under stronger heating, we'll start to decompose the tin tetraiodide, and some iodine will be present in the mix, giving the gas a slightly darker color. Yeah, now we see the yellow color in the test tube go more red, and the tin tetraiodide decompose into a black compound down there. If you look closely above where it's being heated, you can see some of it reflux. Anyway, I hope you enjoyed this video. Thanks for watching.